Hi everyone, this is the section 5.2 video called Dividing Polynomials, and in this section we're going to learn a couple different ways to look at division with polynomials. So the first way that we're going to attack things is when we have the situation of a polynomial being divided by a monomial. So remember, a monomial is a one-termed polynomial, so it can be something like we saw before in section 5.1, like example A, that says simplify negative 12x to the 7th, y to the negative 2nd, over 15x to the negative 3rd, y to the 4th. And we're going to simply, in this case, because the denominator is a monomial, and the numerator happens to be a monomial as well, but it does fit the criteria of a polynomial being divided by a monomial, we're going to follow all of our exponent rules after we reduce this fraction, negative 12/15. So this is going to become, let's see, 3 goes into each of those, so negative 4/5. And then as far as the x's go, when I subtract my powers, I get x to the 10th up in the numerator. And when I subtract my powers for the y's, I get y to the negative 6th. Now that technically belongs in the numerator, but when I write it for my final answer, I'm going to say negative 4x to the 10th over 5y to the 6th. Final answer. So that's a little review of what we did in section 5.1. This is going to expand today to look at something like we have in part B for this example. In this part B, you can see that the numerator has become a little bit more extensive than what we had in part A. So we have a 3-termed polynomial. And the way that we're going to look at this, as long as your denominator is a monomial, we can say that the monomial is able to divide into each term in the numerator. So we have 1 term, 2 terms, 3 terms. So the way that we look at this is 6x to the 4th y cubed gets divided by 3xy plus 12x cubed y squared gets divided by 3xy minus 18x squared y gets divided by 3xy. So you can see that that monomial in the denominator will divide into each term in the polynomial that makes up the numerator. So you don't have to write this out and split it up like this all the time. I tend to do this all in my head, and at your level I kind of expect that to happen with you. So the first term is going to simplify to 2x cubed y squared because we subtract our powers, and 3 divides into 6 twice. The second term will become 4 plus 4 x squared y, and the last term will become negative 6x, and the y's drop out because we're dividing y by y. So this is our final answer. Not very hard, you just have to remember to take the monomial in the denominator, divide it into each term in the numerator, and simplify from there. So if you have any questions on that, we can definitely tackle those when I see you in class next time. Now, the next type, not that it's going to be really different, it's just going to be presented to you in a different way. This is presented, it says simplify 18x squared y plus 27x cubed y squared z multiplied by the quantity of 3xy to the negative 1st. Now, this piece to the negative 1st here, 3xy to the negative 1st, this is really a multiplication problem. So you might be thinking, like, why is this in the division section? If something is raised to the negative 1st power, remember, we can rewrite it with a positive power if we change the part of the fraction that it's in. So this is equivalent to 18x squared y plus 27x cubed y squared z divided by 3xy all to the 1st. So I don't need to parenthesize and raise it to the 1st power because to the 1st power is not really going to affect anything. So I now have a polynomial being divided by a monomial, and I can reduce this to 6x plus 9x squared y z. And that's our final answer. So the 3 goes into the 18 6 times. X squared divided by x is x, and the y's drop out from the first term. 3 goes into 27 9 times. X cubed divided by x is x squared. Y squared divided by y is y. And then we have that z that has no common base in the denominator. So final answer is right there. So the point of this problem is to show you that multiplication can be, division can be implied through the idea of multiplication. So you have to be aware of those kinds of things. If you're multiplying by a quantity that has a negative power, you can rewrite it as a division problem with a positive power associated with it. So we may have to talk a little bit more about that. But those are forms that you should get used to seeing. The next part is going to be dividing a polynomial by a binomial. So that means that the denominator will have two terms in it. And the first method, which is everyone's least favorite, is to use that good old long division that you learned way back in probably 4th grade. So to get you into that, I'm going to do an old-fashioned long division problem just to refresh your memory. If we're dividing 4,325 by 23, we would set the problem up to look like this. 23 is going to divide into 4,325. And then we would look at the 23 and say, well, 23 can't go into 4, but it can go into 43 one time. And then we're going to multiply the 1 times the 23, subtract, and then now 23, after we bring down the 2, has to go into 202, which would be what? 8 times. So 8 times 23 is 4. Carry the 2. That's going to give us 184. So we're going to subtract, and that will be 8, and we'll get 18. And then bring down the 5 last. 23 goes into 185. Well, we know 8 times it brought us to 184. So it'll go in another 8 times with that remainder of 1 because we have no more to bring out. So the old-fashioned way was to write it like this. We can also say that the quotient is 188 plus 1. No, I don't want to write plus. I want to write 188 and 1/23. This is our remainder written over our divisor. If you remember, this number here, the 4,325, is called the dividend, and the 23 is called the divisor. So I need you to just kind of refresh your memory about that because the next problem that we're going to work with is going to involve variables along these lines. So I'm going to move into something like that to show you how we're going to work with the polynomials that we've been seeing in our problems. So these examples say use long division to find x squared plus 3x minus 40 divided by x minus 5. So the first thing you need to do is figure out which is your divisor and which is your dividend. The number that comes after, or the polynomial that comes after the division symbol is going to be your divisor. And the other piece is your dividend. Now you want to make sure that you list all the powers. So we have a squared term, we have a linear term, we have a constant term. If for some reason there was no linear term, like there was no x, I would write x squared plus 0x minus 40 so that there's a placeholder. Now, when we do long division with polynomials, we only focus on the first term in the divisor. And we ask ourselves, x squared needs to get, right here, x squared needs to get divided by x. So x times what will give us x squared? And hopefully you guys are answering x. We line that up over the term that has the same power in the dividend. So once we figure out it's x, we're going to multiply this x by the entire divisor. X squared minus 5x, lining up like terms. Now in regular long division, our next step would be to subtract, and that's what we're going to do in this problem. When I subtract, I end up having to basically add the opposite. So this becomes plus negative x squared plus 5x. So our new signs, the x squared should drop out, and 3x plus 5x is 8x. Bring down the minus 40. Now we're going to go back to the divisor, and we're going to ask ourselves, what times x will give us 8x? And we know that that's positive 8. So we write that up on the quotient line, multiply the 8 by the x minus 5, and that will give us 8x minus 40. And we know that if we subtract, we change the signs and add. So I'm going to change this to subtract the addition, the plus sign that's implied in front of the 8x to a minus sign, and this will turn into a plus. So we notice that both of these drop out, which means we have a remainder of 0. So this means that the quotient of x squared plus 3x minus 40 divided by x minus 5 is equal to x plus 8. This is our quotient. And what we also know is that x plus 8 multiplied by x minus 5, which is the divisor, the quotient times the divisor, will equal what our dividend is if there's no remainder. This is the factored form of that polynomial. So it's all kind of coming full circle with some of the things that we studied a little bit earlier. If our remainder is 0, then that means that what we're dividing in, the x minus 5 as a divisor, is actually a factor of the dividend. And we'll talk a little bit more about that in class 2. Now the second one is one of these multiplication problems that we can switch to division. So I'm going to do this. I'm going to make my divisor negative a plus 3. I'm going to switch it around so that the highest power is first, and that's the way things should be written, is dividing into a squared plus 7a minus 11. So negative a has to multiply by what to get a squared? That's a negative a. We're going to take the negative a, lined up over the proper term, multiply it to the negative a plus 3, and that gives us a squared minus 3a. We're going to change our signs, combine, these are out, and we get 10a minus 11 when we bring that down. Now we're going to ask ourselves, negative a times what gives us positive 10a, and that's negative 10. So that will give us 10a when we multiply through minus 30. Change our signs. These are out. Negative 11 plus 30 is 19. Now we have nothing else to bring down over here from the dividend, so this is our remainder. And we write our final answer as negative a minus 10 plus 19 over negative a plus 3. That's our final answer. This part, this is the new piece from the problem above. That's our remainder piece. This is our quotient. That's our remainder. So the negative a plus 3 would not be considered to be a factor of that original dividend, a squared plus 7a minus 11. We're going to need some practice with it. So I fully expect you to come in saying, I'm not really sure of this, or I don't really like it. I will give you plenty of time to do some practice with it in class when I see you next. So like I said, long division is definitely not the desired method. This second method, which is called synthetic division, is what we would much rather deal with when we're dividing a polynomial by a binomial. The only thing is that the binomial in this situation has to have a degree of 1. And that's what we saw in the past 2 examples. So we have to make sure that the power on the divisor, the degree, is equal to 1. We can't have a squared, we can't have a cubed, we can't have a negative 1 in there. It's got to be a 1. So I'm going to do this problem through what's called synthetic division, and I want you to kind of watch as I walk through it, and then I'll have you write down all the steps. So the way that we do synthetic division is this. We list all the coefficients of every term in the dividend. Now, when I say every term, I mean every single power that should be included. So if our highest power is 2, we should have a coefficient for a power of 2, which in this case is 1. For a power of 1, in this case is 3. For a power of 0 comes here, that's negative 40. If one of those is skipped, we're going to put a 0 in its place, just like I mentioned with long division. Now, we go over to the divisor, and we look at the value that comes after the variable. So minus 5. We put the opposite of what we see in there. So this factor, or this divisor, is really in the form x minus r. So r is equal to 5. What we do is we take that value of r and we put it in like kind of a semi-box to the left of where we listed all of those numbers. Now we do this. We're going to leave a little space, and we're going to draw a horizontal line, and we're going to bring down the first coefficient below that horizontal line. And what we do with that first coefficient that we just brought down is we multiply it by the number in the box, and we write that product underneath the next coefficient. Then we add these numbers together, so we get 8. And we continue in that pattern. 8 times 5 is 40. We write it, and then we combine by addition, and we get 0. Now, the numbers that we get below the horizontal line tell us about our quotient and our remainder. The quotient it comes from every value except for the last number that we have. So we're going to exclude this value here right now. Our original problem was to the second degree. Our answer is always going to be 1 degree lower. So this is going to be 1x to the first power plus 8 because it would be x to the 0 power, and x to the 0 is equal to 1. This number here is our remainder. So because we got 0, there's no remainder to this problem, and that means our final answer I could just write is x plus 8. So x squared plus 3x minus 40 divided by x minus 5, excuse me, is equal to x plus 8. I think we saw that earlier in the other problem, didn't we? This answer right here is not only the quotient, but it's referred to as a depressed polynomial. Not because it's sad, but because it's reduced down in powers. So it starts with a power that's 1 lower than what the original power it was. So we depress the powers as we write our answer. This is really quick once you get into it. It takes you literally less than a minute to do all of these types of problems, which is much more preferable than using long division. So let me do, excuse me, let me do this for you. Let me go to the next couple of slides here that are going to have the steps on it. So the first step is, you should get these in your notes. Be sure that the coefficient of the divisor is 1. If it is not, divide everything through by that value so that it becomes 1. You may have to stop and start the video as you go through this. So we want to make sure the coefficient of the divisor is 1. And if not, divide everything through by that value so that it becomes 1. Step 2 was to write the coefficients of the dividend so that the degrees of the terms are in descending order and they're all included. So all the powers have to be represented. That's when, if a power is not represented, write 0 in for that coefficient value. Then you're going to take the constant r of the divisor. So that's the number that comes after the minus sign. Basically, it's kind of like the parabola, the vertex thing. You take the opposite of what you see in the little half box to the left of all those numbers. And then we're going to bring the first coefficient down after we do that setup, leave that line and put that horizontal, or leave that space and put that horizontal line. Step 3 will be to multiply the first coefficient by r and write the product under the second coefficient. Step 4, let me go to the next screen. Step 4 will be to add the product and the second coefficient together. And then you go through that process until you get all the way to the end of your line of numbers. Every number except for the last number is going to represent your depressed polynomial. So we start that answer 1 power lower than what the original one was. Those are all the coefficients. And the last number is considered to be the remainder. So I'm going to do one more problem here for you that has, excuse me, a little bit more complicated of a setup where we have a coefficient in our binomial other than 1. So the first thing I have to do is divide everything through by that leading coefficient and rewrite the problem. That means that my problem, I'm going to divide everything by 3. My problem is going to become x to the 4th minus 5/3 x cubed plus 1/3 x squared plus 7/3 x is going to be divided by x plus 1/3. So it's turned into a problem that involves fractions, and unfortunately, yes, we are going to get stuck with working with fractions. But they're not going to be too bad. We'll be able to deal with it. I'm going to go from left to right this time. So I'm going to actually put the number in the box first. Negative 1/3 will go in the box because it's the opposite of what I see. Then I'm listing all my coefficients. 1 for the power of 4, negative 5/3 for the power of 3, 1/3 for the power of 2, 7/3 for the power of 1, and 0 for the power of 0. So I have to include that. I'm going to make my horizontal line, leaving a little bit of space, bring down the 1, multiply by negative 1/3, and I get negative 1/3. I add these together. Negative 5/3 and negative 1/3 is negative 6/3, which is negative 2. Multiply these together, I get positive 2/3. 2/3 and 1/3 is 3/3, which is 1. So you see how our numbers are working out. Multiply together, we get negative 1/3. Combine by addition, and we get 6/3, which is 2. Multiply together, we get negative 2/3. Combine, we get negative 2/3. So this last value I'm going to separate from the rest, knowing that that's the remainder. And I'm going to say that my quotient is the depressed polynomial x cubed, because it's 1x, minus 2x squared plus x plus 2, minus now our remainder. This is going to become 2 over, so that's this 2 right here. The minus sign is coming from this minus sign right here. 3 from the denominator times the quantity of x plus 1/3, which is going to be x cubed minus 2x squared plus x plus 2 minus 2 over 3x plus 1. So that is a little bit more of a complicated scenario where we had to go through and divide by that leading coefficient in our divisor because it was something other than a 1. And when we did that, we changed our problem so that it involved fractions. But you notice that when we went through and did everything else, the numbers turned out fairly nice. So it's definitely quicker than doing long division. But again, I'm open to questions. We'll talk about it in class. We'll do lots of practice with it. And it's going to become like second nature for you very quickly. So thank you for listening. Make sure you rewind if you need to get all the notes into your notebook because I went through some of this kind of fast. And I'll see you in class next time. Thanks.